Welcome back to another episode. I remain your favorite tutor. Okay, still on gravitational field. The question on the board. A satellite of mass m orbits the Earth of mass m with a velocity v at a distance r from the center of the Earth. Derive the relationship between the period t of the orbit and what? R. Now this is what past question. Why past question? Okay, it is very simple. Very simple. All right, let me explain this concept using diagram. Okay, let's say this is the what? This is the Earth. The Earth has the bigger mass, m, and this is the what? The satellites, smaller mass. Okay, the distance from the center of the Earth to the satellite is what? This is the distance, r. Okay, and the satellite orbits the what? The Earth. Move around the world, the Earth. Okay, we are looking for a relationship between what? The period and the distance. That's what we are looking for. The relationship between the period and the what? Distance. And it's very simple. First, when we look at this, it looks very confusing. But it's very simple. First of all, this satellite is moving around the world, the Earth. Which force keeps this body in circular motion? Which force is going to keep this body in circular motion? That is what? Centripetal force. You can say, therefore, the centripetal force is equal to what? The gravitational what? Force. That's the gravitational force of what? Attraction is equal to the what? Centripetal force. And what is the centripetal force? Centripetal force is what? mv squared over what? The distance equals to gravitational force. Using what? Newton's law of universal gravitation. That is what? G m mass of the Earth, mass of the satellite over what? Rho square. So here we have it. Okay, so this is mass of the satellite. Mass of the satellite cancel out. This is the distance. So therefore, 1 here. This one is 2. Then is square. So keeping 1 aside. This one is out of the way. So therefore, this square is equals to what? G mass of the Earth over what? Radius. Okay. Now this is the what? The speed of the what? The satellite moving around, orbit around the what? Earth. Okay, but we are looking for what? Relationship between the period and the what? Distance. We already have distance. The period and distance. We are going to connect everything right now. Okay, from this speed, it's moving around the world. This thing is under circular motion. When we look at the simple harmonic motion, we know that what? Speed is equals to distance over what? Time. Distance over time. Now, if this thing orbits, make one revolution, what is the distance? The distance becomes what? If this satellite makes one revolution, the distance becomes what? The circumference of a circle. And the circumference of a circle is what? 2 pi r. This is the what? Distance over time. The time rate for one revolution is what? Period. That is what? T. You can see it now. So if this is v, the speed is equals to this. We substitute it right here so that we can look for the relationship between the period and the what? Distance. So this becomes that. This becomes 2 pi r over what? T. And this is what? V squared. Don't forget, V squared raised to the power of what? 2 is equals to what? Gravitational constant, mass of the Earth, and the what? Distance. Okay, now this looks more simple like this now. We just have to look for the relationship between these two. So this square right here is for everything right here. Okay, that is 2 raised to the power of 2 is what? 4. That is pi raised to the power of 2 plus what? R raised to the power of 2. All over what? This is t raised to the power of 2 is equals to what? That is g n over r. Okay. Now we have the period. Now we have the what? The distance. We have the distance. So we just make this guy subject formula, the period. So if we cross multiply right here, cross multiply, I have t squared gm is equals to this, multiply this, it becomes 4 pi squared, then what? Arrow, take the cube, no longer square, we're going to multiply this, we take the what? The cube. Okay, so divide both sides by whatever is attached to what? The period. So therefore the period is equals to what? 4 pi square, the cube of what? R all over what? Gm. This is the relationship. We are true. This becomes the what? The relationship. But to make it look more good, more okay, if you look at this, this is a constant. 4 does not change. Pi is also a constant. This is a constant. Gravitational constant. This is a constant. And this is mass of the earth. It does not change. It's a what? Constant. All these are what? Constant value. So therefore, we can say that what? The period, this is the power of 2, is what? Directly proportional to what? The cube of the what? Distance. See, this becomes the what? Relationship. It's very simple. It's not difficult. Please, if you need of a what? A private online class, just inbox. And also, please subscribe to the YouTube channel. If you are getting this on TikTok, hit the follow button. I remain your favorite tutor. Thank you, and God bless you.